Bismillahirrahmanirrahim. Nahmaduhu wa nusalli ala Muhammad Rasulullahi Kareem. This problem is related to differential calculus and chapter name is partial differentiation. If u is a function of x and y, value of u is equal to 1 minus 2 times xy plus y square whole power minus 1 by 2. Prove that del over del x 1 minus x square multiplied by del u over del x plus del over del y y square del u over del y is equal to 0. First of all, we will find the value of del u over del x and del u over del y. Here u is given which is function of x and y, which is equal to 1 minus 2 times xy plus y square whole power minus 1 by 2. I write it equation number 1 and differentiate partially with respect to x. Differentiate equation number 1 with partially with respect to equation with respect to x. Differentiate equation 1 partially with respect to x. I mean now consider this value is as x, so x to the power n, formula for differentiation is n x to the power n minus 1. What we are seeing here, this is not x, so according to chain rule we must differentiate this value with respect to x. So differentiate 1 minus 2xy plus y square partially with respect to x. In next step I write it as without any change del u over del x is equal to minus 1 by 2 1 minus 2xy plus y square whole power minus 1 by 2 minus 1. I take minus from these two terms, then both term becomes positive, and because this is fraction 1 by 2, so I write 1 as 1 by 1, so that we will take LCM 1 into in next step, or you can write it as 3 by 2 directly. Differentiate this value. Differentiation of 1 with respect to x is equal to 0, and for x minus 2y is constant, so take out 2y from differential coefficient and differentiate x with respect to x, and also differentiation of y square is equal to 0 because y is constant for x. Now write minus 1 by 2 1 minus 2xy plus y square, and take LCM 2 1 multiplied to this become 1 and 2 multiplied to 1 become 2. You can write this to 3 by 2 directly as I already say you. Minus 2y 2y into 1 2y cancel out 2 to 2, and minus this minus change this minus 2 plus, so we get del u over del x is equal to 1 minus 2xy plus y square whole power minus 3 by 2 into y. Change this power to plus, therefore del u over del x y upon 1 minus 2xy plus y square whole power 3 by 2. And I write it as equation number 2. I will use in future. And next we have to find del u over del y. So differentiate equation 1 with respect to y. We get del over del y. Value of u is equal to 1 minus 2xy plus y square whole power minus 1 by 2. Consider this value, which is written in bracket as y, and apply formula minus we know that this formula x to the power n is equal to n, x to the power n minus 1. Apply this formula for here, n is equal to minus 1 by 2, and consider this value as y. So write this value and apply this formula, and n minus 1. What it is not y, so we must differentiate this value with respect to y partially by according to chain rule. Minus 1 by 2, 1 minus 2xy plus y square. This becomes minus 3 by 2, as I have already solved here. You can easily solve it. Differentiate it by with respect to y partially. 1 is constant, so differentiation of 1 with respect to y is 0. Also 2x is constant, so I take out its and differentiate only y with respect to y, plus differentiation of y square is equal to 2y with respect to y, because y is variable. I apply this formula here, because 2 minus 1 is equal to 1, or and 1 is not necessary to write here because it is default 1. So del u over del y is equal to this. I visit solve it by taking minus 2 from here, so that this value become positive, but this is 2 by 2. 1 minus 2xy plus y square whole power minus 3 by 2, and because I take out minus 2 here, so it becomes plus x and minus y. 2 is cancelled out by 2. We get del u over del y is equal to 1 minus 2xy plus y square whole power minus 3 by 2 x minus y. I write this equation number 3, and now we should find the value of this term after this term, and after that I will add it and we will find the 0. So differentiate. So I find the value of first term, which is equal to 1 minus x square del u over del x is equal to del over del x as this 1 minus x square, and after this I write the value of del u over del x from equation number 2, which is written here. So I write it y upon 1 minus 2xy plus y square whole power 3 by 2. For x we know that y is constant, so take out y from del over del x. We have to only differentiate 1 minus x square upon 1 minus 2xy plus y square whole power 3 by 2. This becomes numerator by denominator, and we should apply the formula for differentiation in numerator. I write formula here. After that I will apply it. Numerator by denominator. Numerator by denominator. Differentiation of numerator by denominator is equal to difference whole square of denominator in denominator, sorry, and denominator right here, and differentiate numerator and numerator as it differentiation of denominator. You see that these are equal. First differentiation numerator and then denominator. So apply this formula. We get del over del x 1 minus x square into del u over del x is equal to y into whole square of denominator, which is equal to 1 minus 2xy plus y square whole power 3 whole up square, and denominator write as it. So I write 1 minus 2xy plus y square whole power 3 by 2, and differentiate partially with respect to x numerator, which is equal to 1 minus x square is equal to 1 minus x square. Now write numerator as it 1 minus x square and partially differentiate with respect to x denominator, is equal to 1 minus 2xy plus y square whole power 3 by 2. On opening this bracket, we know that degree will be multiplied to each other. 3 by 2 multiplied to 2, and after solving we can say that 2 cancel out by 2, only this power is 3. But we should focus on numerator, because after writing y this value and 1 minus 2xy plus y square whole power 3 by 2 I write without change, and differentiate its value. Differentiation of 1 is constant with respect to x, and differentiation of x square is 2x minus, write 1 minus x square as it, and differentiate this value considering it is x, as we already solved this value. You can use direct here, because this is no here power is changed 3 by 2, so we repeat the process, and I apply formula and x to the power n minus 1 to xy plus y square whole power 3 by 2 minus 1, but it is not x, so I differentiate it with respect to x. 1 minus 2xy plus y square, close bracket close. After it y bracket start, I write minus 2x first, and then this 1 minus 2xy plus y square whole power 3 by 2 minus, I write 3 by 2 first, and after it 1 minus x square, and this bracket 1 minus 2xy plus y square whole power 3 by 2 which is 1 and half minus 1, so we get 1. I tell that 3 by 2 is equal to 1 plus 1 by 2. So subtract 1, we get only 1 by 2. You can also solve it, or you can directly write it as if you know. Differentiate it with respect to x. We know that it is partial differentiation, so differentiation of constant 0 0, and also for x 2y is constant, so I take 2y and differentiate x with respect to x, and differentiation y square is 0 because for x y is constant. Close bracket close, whole upon 1 minus 2xy plus y square whole of power 3. Now we can take out this power 1 by 2 power common take out, so y 1 minus 2xy plus y square whole power 1 by 2. Since I already said that 3 by 2 is you can write 1 plus 1 by 2. 1 by 2 is taken out from this bracket, so only one power we can write 2x minus 2x and 1 minus 2xy plus y square whole power 1 minus 3 by 2 1 minus x square, and this quantity is taken out from bracket only minus 2y here. 2 cancel out by this 2, and after that I will change this sign by this, because multiplication of minus 1 into minus 1 is plus 1. 1 minus 2xy plus y square whole power 3 is equal to y 1 minus 2xy plus y square 1 by 2. As you know, the value is equal to first term of which have to prove in left hand side. So because this calculation is very high, I write minus 2x and 1 minus 2xy plus y square. I change this sign by this and write 3y first and 1 minus x square. We can also solve this value and also we can we can collect this power 3, subtract we have to subtract to minus 1 by 2, so 3 minus 1 by 2 equal to 6 minus 1 means 5 by 2. So this value equal to y upon 1 minus 2xy plus y square whole power 5 by 2, because base of this quantity is equal, so I subtract 1 by 2 from 3, because I take this value to denominator. If we take it to numerator, then we have to subtract 3 from 1 by 2. What I do as I tell farmer. Now we will solve this value. So open this bracket, minus 2x multiplied to 1, we get minus 2x plus 4x square y and minus 2x y square. On opening this bracket, we get plus 3y minus 3x square y. We are seeing that these two terms only like term, so subtract 3y square from 4y square, we get only x square y. This is value of this. I write again in next page. Del over del x 1 minus x square del u over del x equal to y. You can see in the previous page minus 2x, and after subtracting we get x square y, minus 2x write as it, plus 3y write as it. Also in denominator 1 minus 2xy plus y square whole power 5/2. We can also multiply y to right hand side. We get minus 2xy plus x square y square minus 2xy cube plus 3y square upon 1 minus 2xy plus y square whole power 5/2. This is value of del over del x, 1 minus x square del u over del x. Now I write it as equation number 4, and also I want to find this value, so that after finding this value we will add these two value and find left hand side, and which become right hand side. Then we reach the proof. So for this value I write the second term del over del y square del over del y, and write y square, and this value of del u over del y is present in equation 3. So this value I write from equation 3. I write this value equation 3, which is equal to 1 minus 2xy plus y square whole power minus 3/2 multiplied by x minus y. We have to differentiate these value. There are 3 functions, so we can write as multiply y square into these two terms, we get xy square minus y cube, and take it to in denominator, and then the sign of this degree is change, power change. 1 minus 2xy plus y square, this power becomes 3/2, positive from negative. We are finding del over del y square del u over del y, which is equal to so we apply this formula: numerator by denominator square denominator, differentiation of numerator minus numerator differentiation of denominator. Here numerator is xy square minus y cube, or denominator is this value. So I write it as denominator whole of square, in denominator 1 minus 2xy plus y square whole power 3/2, denominator whole of square, and write denominator as it 1 minus 2xy plus y square whole power 3/2, and differentiation of numerator, which is equal to x y square minus y cube, and write numerator as it xy square minus y cube, and differentiation of denominator with respect to y, 1 minus 2xy plus y square whole power 3/2. Now we go to next step, is equal to write this value as it 1 minus 2xy plus y square 3 by 2. Now differentiate this value with respect to y. For y, x is constant, so take x as constant and differentiate y square with respect to y, which is becomes 2y, and minus differentiation y cube is 3y square. Minus write this value as it x y square minus y cube, and differentiate this value which is 3 by 2. We apply this formula here. Consider this value as y to the power n, and y to the power n minus 1. So n and y to the power, y means this value 1 minus 2xy plus y square whole power 3 by 2 minus 1. What it is not y, so we differentiate according to this value according to chain rule, 1 minus 2xy plus y square. And on opening this bracket, then power will be multiplied 1 minus 2xy plus y square whole power 3 by 2 into 2, cancel out 2 by 2, and we get 1 minus 2xy plus y square whole power 3 by 2. We can write to first and then xy minus 3y square minus write as this bracket as it xy square minus y cube and 3 by 2. Write this value 1 minus 2xy plus y square. On solving this value we get 1 by 2, because 3 by 2 is 1 and half, so 1 cancel out, only half is here remaining here. Differentiate this value with respect to y, we get 0 minus since for y x is constant, so take out 2x as constant, differentiate y with respect to y, which is equal to 1, and differentiation y square is 2y. Write this value 1 minus 2xy plus y square whole power 3. We can take out minus 2 from this bracket, because we take minus 2 minus, since this value will convert into plus, and next step 1 minus 2xy plus y square whole power 3 by 2, and 2xy minus 3y square minus I write 3 by 2 first, and also I take minus 2 from this bracket, so it become 2, and 2 is from this bracket I write here, and then write this bracket x y square minus y cube, and I write it first, and write this bracket as it 1 minus 2xy plus y square whole power 1 by 2, because I take minus 2 from this bracket, so it become x, since minus is coming from this bracket, so this plus convert to minus, and 2 also take to here. 1 minus 2xy plus y square whole power cube in denominator, 2 is cancel out, and here there are two terms, plus from before plus and after plus, and in these two terms this value is common, but degree is different, because here is 1 by 2 degree, and here is 3 by 2 degree. I take out from common out from this bracket only, which is lesser degree, it is 1 by 2, because in it 1 by 2 is present, because we can write 3 by 2 as 1 and half, If we take out 1 by 2 degree here, so only 1 degree will remain here. So I write 1 minus 2xy plus y square whole power 1, which is not necessary to write 1 here. So I write this value 2xy minus 3y square plus 3 times x y square minus y cube, and I write this value these terms 1 minus 2xy plus y square whole power 1 by 2 and x minus y upon 1 minus 2xy plus y square whole power 3. I committed a mistake here because I have taken out this from this bracket, so this term will not present here, so it will cancel out because I have taken out it from bracket. So only these factors are present here, and collecting these factor, because 1 minus 2xy plus y square is same base, so we can subtract 1 by 2 from 3 and write in denominator, because 3 which is greater than 1 by 2 is present in denominator. So I write remaining degree of this brackets in denominator. 3 minus 1 by 2 equal to 2.5, which is equal to 5 by 2. I subtract 1 by 2 from 3 as on taking LCM 2 multiply to 6 3 equal to 6 minus 1 multiply to 1 equal to this, therefore 5 upon 2, which right here. So this bracket is combined with this, and only I have to write this value. So start from this and we should multiply these two bracket starting from 1 multiply to these two terms, we get 2xy minus 3y square, and after this minus 2xy multiply to these two terms we get on multiplying these two terms we get minus 4x square y square, and when this minus multiply to this minus becomes plus 6x y, and y square becomes y cube. So I multiply this to these two terms, and also third term, first second third term multiply to these two terms, we get y square multiplied to here we get 2xy cube, and this multiplied to this term we get 3y to the power 4. On multiplication degree will be add up, plus I multiply these two bracket and write here, and also we will multiply these two brackets. When x y square multiply to x, it become x square y square, and this multiply to this we will x y cube, and minus y cube multiply to x, minus plus into minus x by cube, and this multiply to this minus multiplication plus, which is equal to 3 power 1 power 4 power, bracket close, is equal to write this value 2xy minus 3y square minus 4x square y square plus 6xy cube plus 2xy cube minus 3y4, multiply 3 to these terms we get 3x square y square minus 3x y cube and minus 3 xy cube plus 3y4. You can do as because these are like term, so it becomes 2xy cube and multiplies 6y cube. It will also become 6y cube. So 1 minus 2xy plus y square whole power 5/2. Here only xy term is 1. There is no other term which is xy, therefore like term only here xy. There is no other term like this, so I write 2xy. I write 2xy 2xy, and after it minus 3y square. There is also not other term 3y minus 3y square. There are only 3y square is single term, so I write minus 3y square here. Minus 3y square. Next I will try to find here is 4 x square y square, but like term here also present x square y square, but this is plus 3/2 and this is minus 4/2. On subtracting, because minus term is greater, so sign will be minus, and remaining value is x square y square, because on subtracting and taking difference in these two terms, we get only minus x square y square. Then these terms are solved, and after it I consider this term 6xy cube, and we are seeing the like term is xy cube here, and this becomes minus 6xy cube. So we can cancel out plus 6y cube and minus 6y cubes. So these terms cancel out, and after it we should write this term, which is plus xy cube, which is not present here, so I should cancel out. So I will write there 2xy cube plus 2xy cube, and we are seeing that next term is minus 3y cube, and this term is plus 3y cube. So this term cancel out. There is no term remain to write here, only denominator, which is nothing but 1 minus 2xy plus y square whole power 5/2. We have solved, we have find the value of del over del y square into del u over del y. I write this value as equation number 5, because we have already given equation number 4, so I write this equation number 5, and we will get result after adding these last two equations, means equation 5 and 4 and 5. Adding equation 4 and equation 5, we get on left hand side of both the equations we get del over del x 1 minus x square del u over del x, and left hand side here in equation number 5 del over del y square del u over del y. What on the right hand side we are seeing in equation number 4 is minus 2xy and plus x square y square and minus 2xy cube and plus 3y square plus 3y square whole upon 1 minus 2xy plus y square 5/2. And on right hand side of equation number 5 we have to add to this term, which is equal to this value. I write 2xy plus minus 3y square minus x square y square plus 2xy cube upon 1 minus 2xy plus y square whole power 5/2. Because left hand side is according to which we have to prove, and on solving right hand side we should take this as LCM, this bracket as LCM. I have not space here, so I write it this term beneath this. So considering these some fraction, this is also fraction, and denominator are equal, so I take LCM denominator 1 minus 2xy plus y square, because these both value are equal to LCM, so I write numerator as it. Or we can solve it another way by taking minus sign from this bracket. Then we will find that this value is positive and this value negative same time, and you can cancel out this and also write answer 0. What you can also do as I write this value minus 2xy plus x square y square minus 2xy cube plus 3y square. This is value of numerator first term on and plus numerator of second term 2xy minus 3y square minus x square y square plus 2xy cube. On opening bracket we are seeing that this value is positive, this value negative, cancel out. Also these are like term plus minus, and all terms are cancelled because these are like terms and opposite sign. So only 0 is remaining here, and after dividing by this value we get 0 divided by any value other than 0, and we get 0, which was to be proved, which is equal to del over del x 1 minus x square del over del x plus del over del y square del over del y, which is equal to 0. We get 0 as proved. Thank you very much indeed for listening me. Wa akhiru da'wana alhamdulillahi rabbil alamin.